Okay, good morning, afternoon, or evening. Welcome back to Mr. Morrow's Algebra 1 and 2 class. We are moving on here, and now we're still going to be dealing with polynomials, but this time we're going to use all of the laws that we learned of exponents and polynomials, and we're going to reverse those laws, and we're gonna do what's called factoring. Okay, we're going to be factoring today. Now, in order to multiply by and factor out monomials, you must remember your power or exponent rules and the distributive property. We just had a test on this. This should take us about 3 seconds. It's not a big deal. Please remember that when you have a to the m times a to the m, you keep the same base and you add the exponents. Okay? Keep the same base and add the exponents. When you have a to the m divided by a to the n, please remember that you keep the base and you subtract the exponents. Please remember that when you have a to the m raised to the n power, when you have a power raised to the power, you're going to keep the base and multiply the exponent. Okay, I'm sorry about that interruption. A to the m raised to an n power, you keep the base and you multiply the exponents. And then I have here, of course, the distributive property. And this is n times parentheses a plus b plus c plus dot dot dot. You can have as many terms as you want. Remember, the distributive property allows you to multiply the outside term, okay, by every single term within the parentheses. Okay? Let's do it. Any questions? Yeah, Mickey Mouse review. Let's do it. All right, let's go further. Now, luckily I wrote this out for you guys on your notes. So if you didn't print out your notes, you're doing a lot of writing today. Please pay attention to this. I know it's long. It's going to be verbose, but I want you to really understand this. In order to understand factoring monomials from polynomials, you must remember what a factor is. Okay, a factor is any real number or polynomial that goes into another real number or polynomial evenly without remainder. For example, the factors of 20 are 1, 2, 4, 5, 10, and 20. All of those numbers divide into 20 evenly without a remainder. That's what a factor is. The factors are basically the numbers that you multiplied together to get the answer you're looking for. Okay? The GCF, or the greatest common factor, is the largest common factor between two or more terms or numbers. For example, the GCF of 70 and 40, well, the factors of 70 are 1, 10, and 7. The factors of 40 are 1, 4, and 10, and 2. What's the GCF? It's going to be 10, okay? Because it is the largest number that divides evenly into both 70 and 40. You got to know your factors. How do you know your factors? By knowing your times tables. Okay, if you know your multiplication tables, this is going to be a joke. If you don't, I would get on it, please. Now, how does this apply to a polynomial? In essence, factoring a polynomial reverses multiplication. That's what factoring is, roughly. So when you are factoring any polynomial, the first step is to find the GCF, if any. Sometimes you're going to have polynomials, bless you, polynomials that do not have a GCF, so you can't take anything out. Oh, well, no big deal. But once you do find that GCF, okay, you factor out that term by dividing the GCF to every term of the polynomial and placing the GCF outside of the parentheses like so. For example, let's say I have 4x squared plus whatever, 2x. What's the GCF of 4 and 2? What's the GCF of x squared and x? X. So, you're basically dividing the GCF to everything. But since you're factoring, you're not solving. You're not dividing that to the other side. You're not getting rid of that. You're just pulling it apart. You're going to put your GCF, 2x, GCF, times the leftovers, which is term 1 divided by the GCF, in this case is 2x, plus term 2 divided by the GCF, in this case is 1. So it's my GCF, and then these are the leftovers after you have already divided the GCF from every single term. And then red here, I put in red so it could stand out. The GCF of like variables always belongs to the variable with the lowest exponent. For example, x to the 6th, y squared, and z to the 5th, and x to the 8th, y to the 5th, z cubed. Remember, we're trying to find out the factor. What number goes into another number evenly? I've got 6 x's here and I got 8 x's here. Can't I take 6 x's from here and from here? So it's the lowest exponent, x to the 6th. I have y squared and I have y to the 5th. I can take y squared out of both. So again, y squared, it goes to the lowest exponent variable. Z to the 5th and z cubed. I can take 3 out of both. So again, it goes to the lowest variable exponent. So the GCF of variables always belongs to the lowest exponent variable. That makes sense, guys? Well, guess what? Let's start factoring. Factoring the GCF is, I think, in my opinion, the most important because it sets everything up for more complicated factoring, and it sets everything up for when you want to break things down. Okay, it's a very nice way to simplify your life and make things easier. So if you know your math, this is going to be easy. Okay, for number 1, what's the GCF here, guys? We got a 5 and x cubed. Very good. I got 3 x's here, 4 x's here, 5 x's here. I can take 3 from here, here, and here. I cannot take 5 x's from everything, correct? I cannot take 4 x's from everything, correct? What is the lowest exponent here? 5, 4, or 3? So the GCF of variables always belongs to the lowest exponent variable. So now that I have 5x cubed, what are my leftovers? 2x squared plus 4x. That's okay, you're human. Minus 3. Boom, done. Goodbye. Have a good day. My GCF is out here times the leftovers. Remember, my friends, you always got to show that that GCF came out. Unless we're solving, which we're going to get to that soon enough. When we're solving, then we can divide it out to everything. But for right now, we're factoring. I got to show my GCF and then the leftovers. Yes, sir.
So they're basically giving us the answer that we're finding the question.
Yeah, that's a great way to look at it. He said they're basically giving you the answer, the expanded version, and what you're doing is you're breaking it up into the factors. Yeah, you're basically breaking it down into, okay, what times what gave me this here? That's a great way to look at it. What times what gave me this huge 4-term polynomial? So what goes into all of these? What's the numerical GCF here? 2. And what's the variable GCF? Q, because it belongs to the lowest exponent variable. All right, guys, give me the leftovers. Spit it out. 2q cubed. That's a tongue twister. Go. Minus 5q squared. Go. Plus 8q. Go. Minus 20. Yeah. Nice. That makes sense, boys. I'm giving you a lot of examples here. Why? Not because I want to be mean, but because I want you to get used to recognizing when there's a GCF. I'm telling you, as we go further and further along, it's going to be really useful for you to be able to identify that GCF. Boom, right now. Okay, what's the GCF of number 3, my friends? 4y cubed. I like the intensity. What's the leftover? Go. Y cubed. Go. Minus 7y to the 6. Good, go. Plus 4. Is that in standard form here? No, it doesn't really matter. Can you rewrite it in standard form? Sure. But it doesn't really matter right now. Okay? Does that make sense? Excuse me. Okay, number 4. What's GCF, y'all? No, R is not the GCF. 2. No, 2 is not the GCF. So this is called prime. If I can't factor out a GCF, it's prime, y'all. It's prime. And actually, ooh, no. This is going to be, that's going to be 2, 6. No, this is going to be, you know what? That's not prime at all. You just don't have a GCF. Because I can factor this by grouping, which is what we're going to do in about 2 minutes. So no, so there's just no GCF. So you cannot factor out a GCF from there. You cannot factor out a GCF. Yes, sir. How when it's prime, it's unfactorable. But that is factorable. I just haven't shown you yet how. Okay, number 5. How can I factor GCF from here? What's my GCF? No. Oh, yes, yes. X, that's it. So what are my leftovers? Uh-huh. Uh-huh. Very good. And last but not least, what's my GCF here? 8. Very good. So I'll be left with P. Yes. Yes, that goes in 13 times if I'm not mistaken. I mean 14 times. Yes, I'm right. No. Oh, no, 8 does not. So 4. 4, thank you. 2p plus p cubed plus 7p minus 4p squared minus 28. What? I'm dividing by, I'm sorry, 8. Yes. Thank you, sir. Good man. Well done. Good catch. Make sense, everybody?
Yeah.
Okay. May I continue?
Yes.
All right. Now, factoring by grouping. Oh, yeah. Easy stuff. People look at this, they get scared. No longer. We're going to get rid of all the factoring fear today, okay? I'm going to give you procedures. I promise you, if you follow these procedures, you're going to have no problems at all. Sometimes you will have 4-term polynomials. When you have 4 terms, this is an indicator to you that I have to factor this by grouping, okay? So when you have 4 terms, okay, this is a very easy process which involves factoring out the GCF from binomials, whereby you create identical binomials. Basically, you're going to create 2 binomials from this 4-term polynomial. And it's actually quite simple. Let me show you step by step. Number 1, group the terms with common factors, forming 2 binomials by using parentheses. So I'm going to go ahead and put a parenthesis here and here, and also here and here. Notice that I'm keeping that sign inside of the parentheses. Okay? Keeping that sign inside of the parentheses. So number 1, to make it neat, all I did was I took the first 2 terms, put them in a parentheses. Second 2 terms, put in a parentheses. Okay? Does that make sense so far? Number 2, factor out, see how important the GCF is? Factor out the GCF of each binomial, which must, there is no choice, leave you with 2 identical binomials. So from this one, I can factor out a 3n, giving me 3n times n minus 4. From here, I can factor out a positive 2, giving me n minus 4. Does everyone see how and why I did that? Everyone. Do you notice that I created 2 identical binomials? Okay, now think about this. Doesn't this binomial have n minus 4? And doesn't this binomial have n minus 4? Well, step 3 says factor out the common binomial and group the leftover GCFs as its own binomial. So let's go ahead and take the n minus 4s, factor it out, and then what am I left with? A 3n minus 2. Minus 2. Plus 2. Plus 2. Does that make sense what I just did there, guys? You promise. Sir. It didn't get changed into a 3n. Thank you for asking. Okay. You see how n minus 4 and n minus 4 is one term. They're both the same term, right? And they're in both of these guys, right? So I'm going to factor out the n minus 4. When these are gone, I divide both by n minus 4. Am I not left with a 3n plus 2? Do you guys see that? I'm going to do it again. Look. You guys have two terms here. 3n times n minus 4 and 2 times n minus 4. But the n minus 4 is a common factor between both terms, right? So when I factor out the common factor of n minus 4, when I divide this by n minus 4 and this by n minus 4, what am I left with? A 3n plus 2. That make sense? Giddy up, that's it. And then check your work. If you're ever in doubt, you're like, I don't think I did this right. This is wrong. Check it. Go ahead and multiply. Again, a skill we've already learned. Go ahead and FOIL. You got 3n squared minus 4. Oh, that's wrong. That's minus 12n plus 2n minus 8. So there's going to be 3n squared minus 10n minus 8. And was that the original question? Yes. Because what's negative 12n plus 2n? 10n. You with me? Any questions on that? We're going to do a bunch of practice now. But any questions on the procedures? Sir, thank you. Okay, doesn't matter which order. What property allows you to change the order of multiplication without changing the product? The commutative property. Yes, sir. So it does not matter. You could have written it as n minus 4 times 3n plus 2. What you cannot do is mix and match. You can't go 3n minus 4 and n plus 2. You cannot do that, okay? Any other questions, guys? Great job. Okay, let's move on. Let's factor each, y'all. Let's do this. Okay. I got 3 terms here, so am I going to group it? No. Let's see if I can factor out a GCF, though. Can I take anything out of here? Is there a GCF here? I could take 8x to the... 8 doesn't go into 36. Exactly. 4x cubed. Very good. So it's going to leave me with 9x squared minus 6x plus 2. Done. Bye-bye. Have a good day. Done. Bye-bye. Okay, number 2. I got a binomial. Is that grouping? No. What can I take out of both of these bad boys? This is a good one. Something x, somebody said. That's great. That is absolutely fantastic. That was great. Hold on. I'm going to pause here because I'm not going to waste time. You guys figure this out. Hold on. Okay, after much collaboration, my class has figured out that 48x is the GCF. And this is negative 7x cubed plus 6 squared. Thank you, son. Thank you. Excellent job. Okay, let's move on. Now, what can I take out of here? Negative 3x squared. Absolutely. Giving me x. X plus 11. Very good. Next, number 4. How many terms do I got? I got 4 terms here, right? Okay. Let's see. Let's try to group these, but okay. Okay, let's see here. This is actually a great one, and I love this one. Okay, look. Check this out. From here, I can factor out a 5z cubed, right? So I got 5z cubed, which gives me 1 plus 2z squared, right? What can I factor out of here to give me a 1 plus 2z squared? Really? 45 divided by 15 is 3. No. Yes, sir. Ah, okay. Much better way to think. Good. Someone's thinking. Guys, can't I factor out a 5z cubed from everything? So now, so now I have 1 plus 2z squared minus 3z plus 9. Okay, so now look at what happens here. I got 5z cubed, and then I've got, no, yeah, that ain't going to work. It's going to be 2z squared minus 3z plus 10. So when I factored out the GCF, I was able to make a trinomial, and now I don't have to do grouping. Yeah, I got a trinomial there. Sometimes if you factor out a GCF, yes, and you can combine like terms, you get a trinomial. Now you cannot group. Does that make sense? Yes, sir? Okay, that was a very good question. When you group, he said, do you get the first two and the last two? No. Sometimes you have to rearrange it. Okay? Sometimes, usually, if that doesn't work, switch this guy with this guy. And then it usually will work. Okay? Thank you, sir. All right. Let's check some. Yes. No. No. The question was, in this case, if you tried to group it. Let's say you didn't do the GCF. Let's rewrite this. So we have 5z cubed minus 15z to the 4th plus 10z to the 5th plus 45z cubed. Okay, from this guy I can take out a 5z cubed, which gives me 1 minus 3z. Think about it here. Am I ever going to get a minus out of this guy? Am I ever going to get just 1z left over? No. So that would not be a good grouping candidate. That could only be GCF. That's why it's so important. It's a great question, son. So important always to first factor out the GCF. Okay? Okay. Okay. Let me do 1 second. All right, guys. Let's go ahead and give you some more grouping examples, okay? I'll just say factor each. You're going to have to actually write this by hand. I know, it's crazy. All right, so let's do this. Let's go 4x plus 4y plus bx plus by. Okay. We got 4 terms. Always glance for GCF. There's nothing here. So let's go ahead and group it. Group that guy together with that guy. Trust me. Keep that variable inside. It's going to come in handy later. From the first term, I can factor out a 4. So I got 4 times x plus y. From the bx plus by, I can factor out a b. So I got x plus y. And now, here's the key. I got an x plus y in this term and an x plus y in that term. So I can pull out 1x plus y. And I have a leftover of b plus 4. Does that make sense? Okay. You with me, guys? All right, let's continue. Let's do another one. Let's do, how about this one? Let's do 6az minus 2a minus 9bz plus 3b. Okay, pay attention. Here's where the minuses come in handy. This is a very good question. Go ahead and group your first two always. If that doesn't work, remember guys, if that doesn't work, put this guy here and put this guy there. Okay? If it doesn't work the first time, just switch the middle ones. Trust me. So from this first term, I'm going to take out a 2a, giving me 2a times 3z minus 1. And from here, I'm going to take out, what do you think? No, not a 3b. A negative 3b. If I take out a 3b, guys, look at what's left over. A negative 3z plus 1. Is that what I want? I need a negative 1. So that's why it's very important to keep that negative on the inside. So I'm going to factor out a negative 3b, giving me now positive 3z minus 1. Now I have two identical binomials in both terms. So I can factor out the identical binomial times the leftover GCFs. Does that make sense to me? To you? Is that making sense here, guys? All right, let's do a little bit of a. Let's try to get complicated here. Let's see if I can do this. So yeah, it doesn't really get too much more complicated. How about this one? Let's try mn plus 2m minus 3n minus 6. All right, let's see what we can do here. We'll go ahead and factor by group, and we're going to separate them here. I can factor out a 2m here, right? No, not a 2m, just an m. So I am going to have m times n plus 2. Then if I want this second term to look like an n plus 2, what do I got to factor out of here? A negative 3, very good. So I got n plus 2. Now I have n plus 2 and n plus 2 identical binomials. Take those bad boys out. And I am left with my two leftover GCFs of m minus 3. Does that make sense? Okay, what if I give you this one? Okay, let's see. The answer was right here, my man. M plus 2 times m minus 3. How about this? AB minus 10AB plus 4 minus 5A. Okay, let's see what we got here. I'm going to go ahead and group them. What can I factor out of this first term here? 2B. Very good. It's going to give me a 4 minus 5A. Very good. What can I factor out of here, though? That's already 4 minus 5A. Very good. You factor out a 1, y'all. Very good job. Excellent. Now I have both binomials identical. I can factor out those binomials. And I've got my 2b plus 1 left over. Yes, sir.
Sometimes if we don't see that GCF of 1, we can combine the 8b and the 4 too, and the negative 10ab and negative 5a instead of the answer.
No, absolutely not. 100% not. No. The question was, if we don't realize there's a GCF here of 1, we can just combine the 4 and the negative 5a? No, absolutely not. No. No, you cannot do that. You have to factor out the 1. No, you have to. There's no choice. So the question is, if I don't see the GCF, you get it wrong. That's the answer. I'm sorry. Sir. If the polynomial is more than 4 terms, then we're going to use what's called the fundamental theorem of algebra and the rational roots theorem, and we're not there yet. So for right now, if it's more than 4 terms, you can look for a GCF maybe, but we group with 4 terms. 5 terms or more, we have to first factor something out by, like I told you, the fundamental theorem of algebra, and then we can factor. Any other questions, though, on GCF or grouping? All right, thank you very much. Have a great day, and I hope you learned a lot.